This is going to be a series of videos dealing with basic concepts and modeling of objects in Fusion 360. Fusion 360 is an Autodesk product that has its uses in industry. While not as popular as other CAD software, Fusion 360 is a good beginning platform from which to learn the concepts. Another benefit of Fusion 360 is that it is free for those individuals involved in education. Students and teachers or professors or anyone with an email address ending in .edu. I'm not going to go into detail on how to procure Fusion 360 in this video. For that, please watch other videos put out by the Electrical Engineering Department here at UTA. For this series, we will be modeling and discussing later how to physically produce a safety razor. We will be referencing a technical drawing, which will be produced at the end of this series, but for the sake of being able to follow along with this tutorial, a copy is available through the official UTA Electrical Engineering GitHub page from the link provided, or by searching GitHub for UTA EE. The first video of this series deals with the handle of the safety razor model. As it is a cylinder, this will show you how to model cylindrical objects and discuss use of revolving, mirroring, circular patterning, and a primer on sketching and creating threaded holes. So let's jump in now and see how we would model the handle of a safety razor. The first thing we are going to do after opening Fusion 360, either for the first time or if you're beginning a new project, is to create a new project folder and save our model in that space. This is done by opening the data panel. If it's not already open, click the grid of boxes at the top left of the screen. The data panel is where you can access stored projects from your Fusion 360 account, as well as libraries and configurations, settings managed by Fusion 360. At the bottom, there's also a training section you can search through if you have a specific problem with a concept, or you want to see how Fusion 360 can accomplish a task, as well as some sample projects to better understand the capabilities of Fusion 360. We won't be using those today, but it's good to know where your resources are. We will be creating a new project by clicking the blue New Project button at the top of the data panel. Give your project a name. In this case, I'm modeling a safety razor, so I'm going to call this project the ever so creative name of Safety Razor, but you can name your project whatever you wish. Once you have a new project, I like to go ahead and save my model before actually modeling anything in that project folder. Fusion 360 attaches a version number to every save you make of a model, starting with version 1 and increasing each time after you save. Once you save a model, you will also notice the label in the tab at the top has changed to reflect your current model name and version number. Again, you can be as creative or as specific with the model names as you want. The first thing we're going to do to begin our modeling of our razor is to create a sketch. A sketch is just that, a drawing. It's where we draw and add dimensions to our model. We will first sketch the circular base of our model. We simply click Create Sketch from the top menu and select the face we want to sketch on. In this case, we will be sketching the main circular outline of the safety razor handle, so we choose the XY plane on which we sketch. Notice once we've selected the model space has rotated to view this plane straight on. You know this has happened due to the rotation of the labeled box in the upper right-hand corner that defines the cardinal sides of our model. We will begin our model by drawing a circle. To draw any shape, you simply select the design menu you want to draw from the Create menu on the Sketch tab. We click the Circle Drawing feature. This allows us to create a circle with a defined center location. I place the center at the origin, that checkered patterned point on the sketch, in order to simplify some future measurements and actions, but you are free to place the circle wherever you feel you need it. Once you have selected the center of your circle, you simply drag the circle to a reasonable size. We will define its final dimension in just a moment. Once drawn, we can define the dimensions of any line or shape we've drawn by going to the Create tab and selecting Sketch Dimensions, or pressing D on the keyboard. We select the object that we want to add the dimensions to and write the dimension in the pop-up box. This is the dimension given to our object, and that will show up on technical drawings or blueprints or plans for our parts. In this case, our handle is 13 millimeters outside diameter. Once we have finished any details we wish to add to our sketch, we click the green check mark in the Sketch tab labeled Finish Sketch on the right, or right-click on the object and select Finish Sketch. This takes us to the Solid tab, where we will create the actual model with the sketch we just made. In the case of our razor handle, we will extrude, that is the technical term for the act of shaping a material, such as metal or plastic, by forcing it through a die. We click the Extrude button on the Solid tab and are presented with a pop-up. Here we are presented with a couple of options. The first option that we have is type. There's two types of extrusion that Fusion 360 allows. The first is a thin extrusion. Thin extrusions create a shell, thin single layer that is hollow to the middle. This is not what we want, so we will stick with the normal extrusion. Next is the profile selection. Because we only have one drawing, the profile we wish to select has been selected for us. There are times that you may want to exclude certain parts of the drawing, or you may want to include certain parts of the drawing. This is where you would make that selection. Next is the start location. Here you can choose where this action begins. If you want to have an extrusion begin some distance, either positive or negative, from your drawing, that is an offset beginning, and it can be defined here. We want our extrusion to begin in the plane of the drawing. Thus we will leave this option set to profile plane. Next, we choose if we want the extrusion to be one-sided, that is to extend from the start of the extrusion in one direction, two-sided, the extrusion would extend from the start in both directions some amount, or symmetric, that is the extrusion extends from the start equally in two directions. We want to measure from the bottom of our handle upward, so it helps to have the origin at the bottom, so we will choose the one-sided extrusion. Next, we see the extended type. This is where we will choose how far to extrude, either a set distance until an extrusion reaches another object or plane of our choosing, or all, which means the extrusion will continue indefinitely. This is used only for cutting actions. Lastly, we have the operation choice. This is where we will define what we are actually creating with this extrusion. We can create a couple of things, either a new body, where wherever the extrusion happens creates a solid body. We can join our extrusion to a current body by joining, which is wherever there is not already a solid object, the extrusion will create an additional solid from that object. We can cut, which is the removal of solid objects from within its boundaries. We can create an intersection. Whatever is inside the extrusion boundaries and what is already a solid object is what will be left. As this is the first solid we will be creating, we will be using a new body function. To complete this action, I like to rotate the model to see which direction I'm creating the extrusion in by clicking the corner of the homing box in the upper right and zooming in and out with the wheel on my mouse. Because we choose the distance to extrude, we will enter the distance box on the extrusion pop-up the total distance of our handle, which in this case is 89.25 millimeters. We'll press OK to create our cylinder. We can center our cylinder in the screen by zooming in and out with our mouse wheel and moving the model left and right by clicking and holding as we move the mouse left and right. This is called panning in Fusion 360. We can also force the perspective to be straight on either the top, the right, the left, the front, or the back using the box in the upper left corner. Because we're modeling a razor handle and not a smooth cylinder, we need to add detail and an outline to this cylinder to be able to use it as a handle. To do this, we will add a second sketch to our model. This one will be on the XZ axis, 90 degrees to the first, so we will choose that plane and add a sketch to it. Again, the program has rotated us to be straight on that plane and added a sketch pattern to the plane, so we can now sketch the design that we want. But there's a problem. We can't see part of our sketch as it's, quote, inside the model. So we need to slice our model, that is, make it so that the only thing that we see is the object below the plane that we are looking at by checking the slice box on the sketch palette. Notice the gray solid has gone and we are left with a pink cross-section of our model. Being a cylinder and the cross-section in question running through the long axis, we see a rectangle. We see the rectangle cross-section, but we can't use it for any reference points or measurements yet. First, we need to project the geometry onto our drawing. This creates structures in our drawing that are tied to the points outside our drawing. We can use them as references for locations and dimensions in our drawing. To do this, we choose Create, project, include, and then project. We then select the geometry we want to include in our drawing, in this case the rectangular cross section. Notice now the edges of the rectangle have points that are accessible to us in our drawing. From here I can draw a straight line in the midpoint of the two horizontal lines of the cross section. This will be used later as our axis of rotation. The next thing I want to define is the basic outline of our handle, the raised knurl sections and the set in smooth sections, as well as the sloped bottom and curved tops. Notice that each rectangle I make starts from the center axis. The blue box as I start tells me that that object is coincident, that is, the point is on the line, to the axis that I created. If I make a mistake, I can undo my drawing by pressing Ctrl Z or clicking the undo button at the top. I can add dimensions to my drawing by either selecting the dimension button from the Create tab or by pressing D and setting the dimensions that I want to create. I leave it up to you to understand how to read a technical drawing and understand how I'm getting these dimensions that I'm using for this model. If you need help with that, please come by during open lab hours and we can certainly go through that process one-on-one. Once I have a good amount of the profile drawn, I check for accuracy of the drawing. In this case, each line should be coincident to both the center axis and the edge of the projected profile. By attempting to drag the points of the rectangle that I create left and right, I can see if they are correctly constrained. Those that aren't receive an additional constraint. In this case, I make the top edge of each rectangle vertical to the top edge of the rectangle above it. This forces them to be coincident to the edge of the outermost rectangle as it is coincident to the outer edge of the top rectangle. I can make a dimension equal to another dimension by writing that dimension's name instead of a numerical dimension in the dimension box. Or I can set a line equal to another line and they would have the same dimensions. Once I have main structured outline, I begin adding the recesses. This is simply a straight vertical line that is set in from the outer edge by 0.2 millimeters on any recessed panel of the handle. The next thing we need to do is define the curve at the bottom of our handle. At the base of a razor handle, we need to use a spline. Point splines, also sometimes called style splines, provide a way of defining complex curves in a sketch. This gives us that nice sweeping curve that is at the bottom of physical objects that are not necessarily perfectly circular. Once finished, this sketch will be revolved, as opposed to extruded. The revolve command creates T-spline, solid, or surface revolved features by sweeping a sketch and model geometry around an axis. To accomplish this, you select the revolve command from the surface menu and then select the profile you want to revolve. Because we are not simply cutting, the operation of our revolve needs to be the intersection of the current body. This will produce the shape that we desire. Sometimes we want to add sketches not at the origin. In this case, we want to sketch on the top plane of our razor handle. This is easy to do by selecting the top flat face on which we want to sketch. On the top, we're going to simply add a point from which we will define a hole. To define a hole, we simply create a hole. We click Hole function in the Create tab. By clicking the point we created earlier, we can define all aspects of the hole. I leave it up to you to know how to read a technical drawing and to recognize the fact that we need an M4 by 0.7 tapped 12 millimeter hole with a 90-degree taper. Now let's look at how to create feature that is common on metal objects both for aesthetics and practicality. We will be adding knurling to sections of the razor handle. This is accomplished by rotating the shaft on a lathe and applying a cutting wheel in the real world, but is a bit more involved in the digital CAD program to create this feature. We will first use a coil feature in Fusion 360 to create one line of our knurling. The coil feature is under the Create drop-down menu. Here, we are first given the opportunity to define the face we will coil about. In this case, I want the coils to rotate about the positive z-axis, so I choose the xy plane and draw a circle at the origin. The diameter of this circle for our applications is the outside diameter of our part. We will fill that information into the pop-up. On the pop-up, we can choose the direction of rotation, either clockwise or anti-clockwise, the number of revolutions the coil makes. In this case, we want it to complete a quarter of a revolution across its whole height. The height of the coil feature, for us, this is the distance from the second straight section from the top to the bottom, which we will measure in just a moment. We can also choose things like the pitch, which is the elevation height gained in each rotation. And we can look at the section types. In this case, we need an internal triangular pattern. This sweeps an equilateral triangular section profile along the coil path pointed to the inside of the coil. Leaving our distance lower than we need allows us to measure to find the actual distance. Measuring from a model in Fusion 360 is an easy process. Under the Inspect dropdown, you simply find two items you wish to measure the distance between. In this case, I measure the top face of the last tall section at the origin and to the origin. The pop-up shows us the particulars of the first face. Because it is a face, it has certain dimensions such as surface area, etc. And the dimension and then the change in the three axial directions from the origin. The measurement we care about is the Z position. This is how far away that face is from the origin in the Z direction. We can then take that information and edit the coil feature from our timeline below to create one pass of our knurled texture. Once we have one pass of our knurling texture, because our object is symmetrical about the z-axis, we can simply mirror that across the xz plane. This gives us two passes of our knurling texture that are each half of the distance, the total distance traveled by our knurl. And again, because this object is symmetrical about the z-axis, we can simply use a circular pattern to create our final knurled pattern by using a circular pattern and creating an instance of both our mirrored and our created pattern 50 times. You can play with the number of instances that is created to find the most aesthetically pleasing. Here's our model of our razor handle. Next time, we will model another part of the razor using other functions in Fusion 360. We will use the models that we create to produce a technical drawing as well as STL files, and then be able to 3D print or CNC the parts here at our in-house milling and printing facilities. I will see you in another video.